Hello everyone, welcome to Geeky Nerd. Today we will begin the part 5 video of the aptitude topic problems on trains. This will be the final video of this aptitude topic. Before moving into the video, I hope everyone would have become thorough with the previous videos related to this topic. If you have not seen them, please click on the card or the link in the bio. In this video, we will deal with some of the miscellaneous concepts of this topic. Problems would have been solved via both formulae and the traditional methods. Like, share, and subscribe the channel and also convey it to your friends so that they can be benefited. Without wasting any time, let's move into the video. Speed is inversely proportional to time. So this concept we had already dealt with time, speed and distance topic. If two trains A and B start from P and Q, after passing each other, they take T1 and T2 to reach the destinations. So it is given in the question that there are two trains A and B. A starts from P, reaches Q. B starts from Q and reaches P. They meet at a certain point, after which train A takes T1 times to reach Q and train B takes T2 time to reach P. In such cases, if speed of any one of the train is given, we have to compute the speed of the other train. We learned from time, speed and distance that ratio of speeds is inversely proportional to the square root of time taken. That is, speed of train B by speed of train A will be equal to square root of time taken by train A divided by time taken by train B. Let us solve an example to understand this concept. Two trains A and B start from Delhi and Patna towards Patna and Delhi respectively. After passing each other, they take 16 hours and 9 hours to reach Patna and Delhi. If the train from Delhi is moving at 90 km per hour, find the speed of the other train. So it has been given that speed of train 1 is equal to 90 kilometers per hour. Speed of train 2 is the thing we have to find. After meeting, the train 1 takes 16 hours to reach its destination and train 2 takes 9 hours to reach the destination. From the basic concept, we know that ratio of speed is inversely proportional to the square root of time. It can be emphasized as S2 by S1 is equal to root of T1 by T2. So since we need to find the speed of second train, I had given S2 by S1. It can also be given in any format as S1 by S2, but we need to change the right hand side accordingly. We need to find speed of second train, which is equivalent to S1 of square root of T1 by T2, which implies 90 square root of 16 by 9, which is equal to 90 into 4 by 3, which is equal to 120 km per hour. Therefore, if train 1 moves at a speed of 90 km per hour and train 2 moves at a speed of 120 km per hour, then after meeting each other, train 1 takes 16 hours to reach the destination and train 2 takes 9 hours to reach the destination. A train covers distance d between the stations P and Q in T1 hours. For example, let us consider a train traveling between the stations P and Q in time T1. Let distance d be the length between the stations P and Q. If the speed of the train is reduced by A, then the same distance is covered in T2 hours. Initially, the train was traveling at a particular speed, hence it managed to cover the distance D in T1 time. Now, when the speed has been reduced by some quantity, the same distance is covered by the train in T2 hours. Now we need to find the distance between the starting point and the ending point as well as the speed of the train. So the distance between 2 points can be given as speed multiplied by time in general. Therefore, distance is equal to speed A multiplied by T1 T2 divided by T2 minus T1. Similarly, speed is given as distance traveled by time taken. Therefore, speed of the train is equal to A2T divided by T2 minus T1. Let us solve an example using this formula to understand the concept. Train covers distance between two stations A and B in 2 hours. If the speed of the train is reduced by 6 km per hour, then it travels the same distance in 3 hours. Calculate the distance between two stations and the speed of the train. So from the question, we can clearly say that initial time T1 is equal to 2 hours. If the speed is reduced by 6 km per hour, then the time taken to reach the same distance is equal to 3 hours. Now we need to calculate the distance between the two stations and the speed of the train. We know that the basic formula of distance is equal to speed into time taken. Therefore, as per our necessity, the formula can be written as A into T1 T2 divided by T2 minus T1. Upon substituting the known value, we get 36 kilometers. Therefore, the distance between the two stations is equal to 36 kilometers. We can write speed as distance divided by time taken. Therefore, reiterating the formula, it will be given as speed is equal to distance. That is, distance can be written as speed into time taken. Therefore, AT2 divided by T2 minus T1, which is equivalent to 6 multiplied by 3 divided by 3 minus 2, which will give me 18 kilometer per hour. So, it is very clear that at the initial speed of 18 km per hour, train takes 2 hours to reach a distance of 36 kilometers. Had the speed been reduced by 6 kilometers, that is if the speed reduces from 18 to 12, the same distance of 36 kilometers can be covered in 3 hours. Therefore, if the initial time taken and the altered time taken is given, and if the reduced speed is also given, then speed and the distance can be determined using this concept. In crossing two persons, if a train overtakes two persons who are walking with speeds of A and B in the same direction and crosses both of them in time t1 and t2 respectively, then the length of the train. So this concept is similar to the early late or continuation of the early late concept which we discussed with time, speed and distance. So it states that a train is overtaking two persons who are walking with speeds of A and B in the same direction and they cross each other in time t1 and t2 respectively. In such cases, the length of the train can be given as relative speed multiplied by t1 multiplied by t2 divided by t2 minus t1. Here, the relative speed A difference B is given because both the person walk in the same direction as that of the train. Let us solve an example to understand how this concept works out. Train overtakes two persons who are walking at the rate of 4 km per hour and 8 km per hour in the same direction and passes them completely in 18 and 20 seconds respectively. Find the length of the train. So it has been given that speed of the first person A is equal to 4 km per hour. Speed of second person B is equal to 8 km per hour. Let T1 be the time taken by train to cross the first person, which is equal to 18 seconds, and T2 be the time taken by train to cross the second person. We need to find the length of the train. Using the formula, length of the train can be given as A difference B multiplied by T1 multiplied by T2 divided by T2 minus T1. So here speed is given in terms of kilometer per hour. Therefore, we will convert it into meter per second. Multiply each by 5 by 18, we get 40 by 18 minus 20 by 18 multiplied by 18 multiplied by 20, the whole divided by 20 minus 18, which in turn will give 20 by 18 multiplied by 18 multiplied by 20 divided by 2. 18 will get cancelled. The answer will be 200 meters. Therefore, length of the train is equal to 200 meters. Thus, when train crosses two individual persons and the individual time taken for crossing are given, we can easily compute the length of the train using the formula A difference B multiplied by T1 multiplied by T2, the whole divided by T2 minus T1. Since both the persons are traveling in the same direction, the relative speed will decrease, and hence we have given the difference symbol. The distance between two stations is d kilometer. A train starts from P towards Q and another train moves from Q towards P at the same starting time. They meet after a certain time of T hours. If the train starts from P, travels faster or slower than the other train, then speed of faster train will be given by the formula d plus tx by 2t, and speed of slower train is given by the formula d minus tx by 2t. It is given that there are two stations, namely A, B, and the distance between the two stations is D. A train moves from P towards Q and another train moves from Q towards P. Therefore, after a certain interval of time, both the trains meet each other. If the speed of one train is slower or faster when compared to the other, we are asked to compute the individual speeds of both the trains, which we can compute using the formula given here. Let us solve some example to understand this concept. The distance between the two stations A and B is 138 km. A train starts from A towards B and another train moves from B towards A at the same time. Both the trains meet after 6 hours. The train traveling from A to B is slower by 7 km per hour compared to the other train from B to A. Then find the speed of the slower train. It has been given that the distance between the two stations D is equal to 138 km. So, both the trains starting from the same time at different stations meet each other after 6 hours. Therefore, T is equal to 6 hours. The train traveling from A to B is slower by 7 kilometers as compared to the train from B to A. Therefore, X is equal to 7 km per hour. Thus, we can calculate the speed of the faster train and the speed of the slower train. In the question, they have asked the speed of the slower train. Therefore, speed of slower train is equal to d minus tx by 2t, which is equal to 138 minus 6 of 7 divided by 2 of 6, which in turn will give 138 minus 42 divided by 12, which is equal to 96 by 12, which is equal to 8 km per hour. Therefore, the speed of the slower train is equal to 8 km per hour. We can calculate the speed of the faster train if required as speed of faster train is equal to speed of slower train plus 7 km per hour as given in the question. Therefore, 8 plus 7 is equal to 15 km per hour. Thus, we have calculated the speed of the faster train and the slower train using the concept we learned. Through this video, we learned how few of the miscellaneous concepts could be solved using the fundamental and the intermediate concepts of problems on trains. Problems were solved via shortcuts as well as traditional methods. Viewers can choose any method depending upon their convenience. With this video, we have successfully completed the aptitude topic problems on trains. Let's quickly recap of what we have learned across the 5 parts. In the first video, we discussed relative speed and how time, distance and speed gets related to each other when trains cross stationary objects. In the second video, we dealt with the trains crossing moving negligible objects and each other. We solved problems determining either the time, distance traveled or the speed. In the third video, we saw the relationship between time, speed and distance when two trains cross each other and when two trains start from same as well as opposite directions. In the fourth video, we solved problems regarding the concept of extra distance traveled by faster train when two trains travel in opposite directions. In the final video, we discuss some of the miscellaneous concepts related to this topic. I insist all the listeners to practice solving more and more problems to increase their confidence. Like, share, and subscribe the channel and convey it to your friends so that they can be benefited. Until we meet in the next aptitude topic, thank you.